Hi everybody, today I am going to talk about the MRI. MRI is known as magnetic resonance imaging. So it is very easy to perform the magnetic resonance imaging and it follows a 4 basic steps. First step is placing the patient into the magnet. Second step is sending the radio frequency pulse by the coil into the patient. Third step is reception of the signal from the patient with the help of a receiving coil, and fourth step is transformation of that signal into an image by a complex mathematical calculation that is known as a Fourier transformation. So now I am going to explain each and every steps in order to understand how MRI imaging is performed. Actually, our body, means the body of a human being, constitutes 70% water, and the chemical formula of water is H2O, means it constitutes a hydrogen. The hydrogen atom constitutes a positively charged particle that is known as a proton, and the proton is having a spin. So when the patient body or when the body of a human being is not in the influence of a magnetic field, that proton inside the body of a human being moves randomly in various direction, in a random direction. But after we place the patient into the magnet, that proton inside the body of a patient aligns according to the classical theory and quantum theory. The proton which is having a higher energy will align antiparallelly, while the proton which is having a lower energy will align parallelly. The proton which is towards the direction of the applied magnetic field will align parallelly, while the proton which is opposed towards the direction of the applied magnetic field will align antiparallelly. After the proton aligned in a long axis of the patient, that is known as the z-axis, which is also the long axis of the bore of the magnet, the forces of the proton in a parallel and an antiparallel axis cancel each other. But there are some protons that retain their forces in the parallel side. They form one kind of magnetization that is known as a longitudinal magnetization. But my friend, longitudinal magnetization is not enough to produce a MR images. In order to produce a MR images, we require a transverse magnetization. So now question arises, how we will create a transverse magnetization. So second step is we should place a coil over the patient, and with the help of that coil, we should send a radio frequency pulse into the patient. After sending the radio frequency pulse with the help of a coil into the patient, the protons that are moving in the parallel axis will absorb some energy from the RF pulse and start rotating or start spinning in the transverse XY plane, producing a transverse magnetization. The process of absorption of the energy from the RF pulse by the proton is known as a resonance in magnetic resonance imaging. So now when the proton moves in an XY plane or the transverse plane, it moves in a Larmor frequency, producing a signal. Then the third step is this signal is being received by the receiver coil, and after that the fourth step is the signal is being converted into an image with the help of a mathematical calculation that is known as a Fourier transformation. So after performing the 4 steps, we can see the image into the monitor. Okay, so now the question arises, what the Fourier transformation is all about. Actually, the guitar, if we see the guitar is having a 6 strings, and every string is producing a different kinds of a sound. And if we combine that different kinds of sound, then it will produce a one tune. So in the same way, our body generally made up of various kinds of things like bones, muscle, ligament, tendon, blood, water, everything, and these components produce a different kinds of signal intensity as well as different kinds of frequency. And if we combine the different kinds of signal intensity or the frequencies together, then we will get a one image which can be evaluated in order to understand the diagnosis purpose, etc. So this is all about the MRI.